For 40 minutes, nothing. No signal, no voice, no data. 4 human beings, sealed inside a capsule smaller than a studio apartment, vanished behind a world we thought we already understood. And when they came back, they had seen things that changed everything. April 1st, 2026. For the first time in over 50 years, since Apollo 17 in 1972, human beings left Earth's orbit. Not robots, not satellites, people. 4 of them. Commander Reed Wiseman, pilot Victor Glover, mission specialist Christina Koch, and Canadian astronaut Jeremy Hansen strapped inside NASA's Orion spacecraft named Integrity and pointed toward the moon. The mission was called Artemis 2, and officially it was a test flight, a systems check, a dress rehearsal for the moon landing that comes next. But here's the thing about the moon. It doesn't give you rehearsals, it gives you revelations. In this video, we are going to break down what Artemis 2 actually saw, heard, experienced, and why the moon we thought we knew may be far stranger, far more active, and far more alive than science ever admitted. Let's start with what we were all taught. The moon is old, it is dead, it is a quiet, cratered rock, a relic of a catastrophic collision 4.5 billion years ago when a Mars-sized object slammed into early Earth and blasted debris into orbit. That debris clumped together, cooled, solidified, and became the gray world we look up at every night. For decades, this was the scientific consensus. The moon had its moment. Ancient volcanoes, massive impacts, and then it stopped. Geologically frozen, seismically quiet, a museum exhibit floating in space. We knew its near side well. Smooth, dark plains called Maria, ancient lava flows that cooled billions of years ago. We had walked on it, driven rovers across it, brought home rocks from it. But the far side, the side of the moon permanently turned away from Earth, for most of human history, no human being had ever seen it. Not with their own eyes, not in person, not close, until April 6th, 2026, when the Artemis 2 crew swung around the moon at close approach, just over 4,000 miles above the surface, traveling at nearly 61,000 miles per hour relative to Earth. What they saw through those windows was not the moon they expected. The far side doesn't look like the moon we know, where the near side has those wide, smooth lava plains, dark and relatively flat. The far side is ancient chaos, craters on top of craters, towering ridges, thick crust that goes far deeper than anything on the near side. Scientists believe the far side's crust may be almost twice as thick in places, a geological puzzle that tells us the 2 hemispheres of the moon may have formed or cooled in fundamentally different ways. The crew observed and photographed massive impact basins, including the edge regions of the South Pole Aitken Basin, one of the largest confirmed impact craters in the entire solar system. It spans roughly 1,500 miles across and plunges nearly 5 miles deep. To put that in perspective, if you placed it on the United States, it would cover most of the country west of the Mississippi River. But here's where it gets stranger. Buried beneath the floor of the South Pole Aken Basin, scientists have detected an anomalous mass, a concentration of dense material so heavy and so large that it actually warps the moon's gravitational field above it. Billions of tons of something, possibly the metallic remnant core of the asteroid that created the basin. Possibly something else entirely. We don't know what it is. And the crew flew right over it. Then there's the heat. Instruments and orbital probes have picked up unexplained thermal signatures on the lunar far side. Areas radiating more warmth than they should, given the moon's presumed geological inactivity. Some researchers believe radioactive elements, uranium, thorium, may be concentrated in pockets beneath the surface, generating heat from within. A dead world warming itself from the inside. At a precise moment during the flyby, something happened that no technological fix could prevent. The moon came between Orion and Earth, and the radio went silent. For approximately 40 minutes, the Artemis 2 crew were completely cut off from mission control in Houston. No telemetry, no voice communication, no data uplink. The moon's bulk, a world 2,159 miles wide, acted as a perfect radio wall, absorbing every signal. They were alone, more isolated than any humans in history, surpassing even Apollo 13's record, reaching 252,756 miles from Earth. farther from home than any human beings had ever been. Think about that for a moment. Every explorer in human history, every sailor, every mountaineer, every astronaut had some tether to humanity. A rescue team, a radio channel, a beacon. These 4 people had nothing. Just the moon filling their windows, the hum of life support systems, and each other. And when Orion finally emerged from behind the moon, the crew witnessed an Earthrise, watching Earth appear over the lunar horizon, just as deep space network stations on the ground reacquired their signal. The most isolated humans in history, watching their entire world, every person they had ever known, every city, every ocean, rise like a tiny blue marble over the barren lunar horizon. During the lunar observation period, the crew wasn't just looking out windows in wonder. They were working, cameras in hand, narrating what they saw to scientists on the ground who were audibly screaming with delight. What did they capture? First, the Terminator, that sharp boundary between the sunlit and shadowed lunar surface. From this vantage point, shadows stretched across the terrain, enhancing relief and revealing depth, ridges, slopes, and crater rims that are often completely undetectable under full illumination. Scientists received the highest resolution human-observed imagery of these features ever recorded. Second, a total solar eclipse from inside space. The moon completely blocked the sun, creating nearly 54 minutes of totality from the crew's vantage point, far longer than any eclipse visible from Earth. The solar corona, the sun's outer atmosphere, normally hidden by its own brightness, glowed as a perfect luminous halo around the darkened lunar disk. Stars became visible alongside it, something normally impossible when imaging the moon. Third, meteor impact flashes. The crew specifically watched for brief pulses of light from meteoroids striking the lunar surface, space rocks slamming into the airless moon at tens of thousands of miles per hour. These have been theorized and occasionally captured by Earth-based telescopes. But witnessing them from inside the lunar system, from the perspective of human eyes pressed against spacecraft windows, that data is unprecedented. And fourth, the crew named things. Just northwest of the Aitken Basin, they proposed naming 2 small, unnamed craters they had observed, including one they suggested calling Integrity after their spacecraft. A small human act, a mark left not in footprints, but in nomenclature on a world they flew past but did not touch yet. Here is something the headlines didn't emphasize enough. So this mission wasn't just a sightseeing trip. It was a test. And some of what it tested was how dangerous deep space actually is for the human body. Radiation. Beyond Earth's magnetic field, the crew was exposed to galactic cosmic rays and solar energetic particles at levels impossible to experience in low Earth orbit. Every hour outside Earth's protective magnetosphere, the body accumulates damage to DNA, to the central nervous system, to the cardiovascular system. The Artemis 2 crew wore dosimetry equipment throughout the mission, measuring their personal radiation exposure minute by minute. That data will directly influence the design of shielding systems, mission duration limits, and crew protection protocols for every future deep space mission, including eventually Mars. And there's another danger lurking on the far side specifically. The far side of the moon is completely isolated from Earth's radio signals. That's actually a scientific gift. It makes the far side the most radio-quiet environment accessible to humanity, a perfect location for telescopes that could hear faint signals from the early universe completely uncontaminated by Earth's electromagnetic noise. But for astronauts, it means any mission operating on the far side requires relay satellites. There is no direct Earth communication possible from the surface. The 40-minute blackout the Artemis 2 crew experienced, that was a preview. A future crew landing on the far side would need to plan every emergency, every system failure, every critical decision, knowing that real-time help from Earth is physically impossible. The moon is not just far. The far side of the moon is unreachable in ways we are only beginning to understand. So what do we do with all of this? Artemis 2 was not supposed to answer big questions. It was supposed to test a spacecraft, and it did. The 10-day mission successfully validated Orion's systems, proving the hardware works, that humans can survive the journey, that deep space communication and navigation function at lunar distances. But in doing so, it gave us something NASA didn't didn't put on the official objective list. Wonder. The far side of the moon is not a footnote. It is a frontier, a place where the crust is thicker, the craters are deeper, the geology is different, and the silence from Earth is total. A place where something massive and unknown sits buried beneath the South Pole Aitken Basin, where heat sources that shouldn't exist, where the ground flashes with meteor impacts too small for Earth telescopes to reliably catch, where magnetic anomalies paint the surface in swirling bright patterns that challenge our models of how the moon lost its global magnetic field. The moon is not a museum exhibit. It is a mystery in progress. Under the Artemis program, NASA plans to send crews on increasingly challenging missions, ultimately establishing a permanent moon base, and from there, using the moon as a stepping stone toward the first crewed missions to Mars. But before we can do any of that, before we can build, before we can land on the far side, before we can use it as the world's greatest radio telescope, we have to understand it. And Artemis 2 just proved that we have far more to learn than we thought. 4 people flew around the moon. They took photographs. They named craters. They survived a 40-minute blackout in the most isolated silence any humans have ever experienced. And they came back with data and questions. That's the thing about exploration. Every answer is just a better formed question. Every mission strips away one layer of ignorance and reveals 3 more layers of mystery underneath. The moon has been sitting above our heads for 4.5 billion years. We've been looking at it for thousands of them. And in April 2026, 4 human beings flew around it and proved definitively that we are still, in every meaningful sense of the word, beginners. If this blew your mind the way it blew mine, subscribe, because we are covering every Artemis mission as it happens, the next landing, the far side operations, and everything in between. And I want to know, what surprised you most? The communication blackout? The buried mass under the South Pole Aitken Basin? The meteor impact flashes? Drop it in the comments. I read every single one, and the best ones I feature in the next video. See you there.